us start this lecture with a thought process. The main objective of education is to learn how to dance like a flame, giving warmth and light to the people around us. In the last part of this course, we learned basically the fundamentals required to understand the combustion in details. And today onwards, we will be looking at basically about the combustion. And if you look at the combustion is very important and also the part of the heat generation and utilization of fuel for various applications. And the basis of the combustion is basically flame. That does not mean there will not be any combustion where there will not be any flame, but mostly the combustion is based on the flame. If you recall, we had discussed about various modes of combustion. The combustion can be broadly divided into two categories. One is flame mode, other is flameless mode. And if you look at flameless combustion, is basically not very much there, but you can see as a example, like in other words, what are the examples of flameless mode of combustion, or what we call smoldering combustion? Any idea? Basically cigarette smoking, or you can say incense, like burning in the during the puja we do, it will be just smoldering of the biomass which will be used for that, and even sawdust combustions, other thing. Beside this, in recent time there is a man-made flameless combustion also, like where combustion will be occurring in a very broader zone or a wider zone, a wider region than as compared to the flame, which will be occurring at a small or a very thin zone, right. So, a question arises, what do you mean by flame? You might have observed the flame in in your LPG burner, which I have shown here, right, and that means you could see the flame by its color, right. In this case, color happens to be blue, but in some case it will be yellow, some case it will be combination of both, right. And there is another, let us look at example where this is the flame which is consist of blue, yellow and purple color, right, you can see. And this is a flame which you might not have seen because it is not being used very much for cooking food, but when I was a kid, like we had used this one, or we used to use this kind of stove. This is a weak flame, right, using kerosene as a fuel. And if you see, that means as this is being used for heating purposes, for cooking purposes, then it will be giving heat. That means a flame can be defined as a spatial domain, because it occurs in certain domain, right, in a region in which some kind of chemical reaction will be taking place, giving rise to what? Heat and light, right. So, we can define then a flame as a spatial domain in which rapid chemical reactions take place, often emitting light and heat, right. Keep in mind, there might be some flame which may not emit light. For example, hydrogen oxygen flame, it will not really give any light, right, unless there is impurities in the hydrogen or in the oxygen. And if you look at, generally the flame will be propagating, right, but in this example what I have shown in LPG stove and then this kerosene stove which I have shown here, in this flame is being stabilized, not propagating. And the combustion, as I told, it occurs in a what you call localized zone. So, therefore, it can be considered as a localized thin combustion zone. That means, the flame can be considered as a localized thin combustion zone, in which the combustion process will be self-sustained, or in other words, if it is a propagating flame, right, then it will be self-sustaining propagation, right. For example, if I say that if there is a tube which contains fuel plus oxidizer mixture, if I ignite it, this is a igniter, right. Igniter means you are giving certain amount of energy of heat or a spark, such that it will be giving you some kind of heat, initial heat, and then flame will kernel, ignition kernel will be formed, and then it may spread to the mixtures, fuel air mixture, it may move with certain velocity, right. And that is known as a propagation flame. This is a flame which is basically propagating, right. This is known as flame propagation, right. Flame will be moving at a certain velocity, right. And this we call it as also a combustion wave, because it is having certain motion. But in case of any application, particularly stove or the combustor, we try to stabilize the flame, otherwise we cannot use it, or it will be little dangerous to have that. But however, flame propagation do occur in mixture, right. Now, let us look at the how to classify a flame. The flame can be classified on various bases. One is the extent of mixing, right. The extent of mixing of fuel and oxidizer we can classify, and we can also classify based on what you call the physical state, like whether it is a gaseous fuel flame or a liquid flame, right, or a solid fuel flame kind of things, we can do that. So, based on fuel oxidizer mixing, we can divide the flame into three categories. One is pre-mixed flame, other is non-pre-mixed flame, and the third one is partially pre-mixed flame, right. And based on the flow characteristics, we will be also basically dividing the flame like laminar flame and turbulent flame. So, what do you mean by this pre-mixed flame? You know that from the name itself, when the fuel and oxidizer are pre-mixed before the combustion takes place, we call it as a pre-mixed flame. And this fuel and oxidizer basically mixed well at the molecular level. The examples you might be knowing, the Bunsen flame, and it is the Bunsen who made this premixed flame into existence in this world. Otherwise, most of the flames are nature are basically the diffusion flame. Okay. But the man-made flame is basically premixed flame. In other words, the premixed flame is a man-made, and it is having also the good properties, and it is having certain also bad properties. Let us look at the fuel and oxidizer when mixed and ignited from a tube, as shown here. You will get a flame like that, which looks to be having a conical shape, right, and this is your flame zone, you can say, and there is a also the dark zone kind of thing, which we will be discussing little later on. And keep in mind that this is the premixed flame, and this premixed flame will be very useful, particularly in modern times, due to the like a concern for the environment. So, what are the examples of premix flame? Any idea? I have already shown you LPG stove burner, right? That is nothing but a premix flame, right? You might be wondering, like, I am just giving the fuel, I am not giving air. Are you giving, whenever you are switching on the LPG line to initiate the to ignite the flame in a burner, do you supply any air? No, no. But from where does the air comes, and how does the premixing occurs in a Bunsen burner, in a LPG stove, is a question which you need to explore. So, the Bunsen burner, of course, I have told he is the first person to design this burner and stabilize the flame, and LPG domestic burner, not only LPG, even CNG or any other kind of gas you can use. And the spark ignition engines, which we call it basically auto engine as such, auto cycle engines. In that case, the fuel and oxidizer means air, are mixed in a carburetor, right, and then it is being fed into engine, and the flame which is generated inside the piston cylinder, inside the cylinder, is basically premix in nature. Beside this, afterburner in jet engine is nothing but your basically premix flame. And these are all, if you look at afterburner, in case of afterburner, what we use as a fuel is basically liquid fuel, the ATF, aviation turbine fuel we use, which is nothing but a modified kerosene. And but in case of SI engine, what do we use? Gasoline. Gasoline will be in which form? Will it be in the liquid form or a gaseous form? It will be in basically liquid form to start with. After that, it will be evaporated, and then it is being mixed properly before it fed into the cylinder of the engine. It is basically gaseous form. Therefore, it is a gaseous mixing. And LPG domestic burner, nothing but your what you call gaseous fuel, and these are premixed. But is there any example where the fuel and oxidizer will mixed in the solid form? Any idea? We do use it for, not for rocket engines. What do you call that? Propellant. Propellant is fine, but what kind of propellant? What kind of propellant? Double base propellant we use, right? S band. What? Polybutadiene. No. Not hydrogen. Hydrogen are liquid fuel. Okay, those are not. You are talking about liquid, right? Hydrogen is liquid, not solid. Okay, you are talking about CTBT. The cyclo terminated polybutadiene, right? That is not the case. It is basically the double base propellant which is being used, and that is an example of a solid premix kind of propellant, where flame would be premix in nature. And so how to characterize a basically premix flame? Because we need to understand whether it is a good or it is a bad, or how it is, how we will have to characterize. We will be using a parameter known as burning velocity, right, which we will be discussing further, because the velocity with which the combustion wave will be moving with respect to the unburned mixtures is known as the burning velocity, which we will be discussing about little later on. Now, let us look at based on flow characteristics, as I told, it can be laminar, it can be turbulent, it can be also transition in between laminar and turbulent, right. So, if this flame is basically if you look at, it is a laminar flame. You can see it is looks to be very smooth, and then we have already discussed about the nature of the laminar and the turbulent flow. And if you, and then this is a burner which shows that it's like a turbulent which is having some structure, and it is having a flamelets which will be overlapping each other, right, in this case the turbulent. And there is another turbulent flame which is having very nice structure, looks to be very artistic in nature, and this we have seen already. This is basically a blob body stabilized flame, diffusion flame, right. And why turbulent flame is important? Because it will be giving you a higher heat release rate. So therefore, turbulent flame are being used very much in practical combustion devices. And keep in mind that in this course, being the first level, we will be mostly discussing about the laminar flames, but however, I will be trying to give a flavor of the turbulent flame as well, right. Now, the diffusion, in case of diffusion flame, the fuel and oxidizer are mixed in the region where the chemical reaction takes place, right. In other words, fuel and oxidizer are mixed on the surface of the flame itself, right. As I told earlier, it is like your marriage. I had related that fuel and oxidizer, basically you can consider one is male and female, like and then the marriage will be occurring, that means arranged marriage, right. That means you will be trying to understand each other while experience going on or interaction going on. So whereas the premix flame you mix together beforehand, and then we get married, and which is inherently unstable. Premix flame basically inherently unstable in nature. And the examples are, I have shown you, that is basically fuel and oxidizer, both are not mixed, they are getting out from these concentric tubes, and then flame is formed, you get a diffusion flame, right. And keep in mind that this is diffusion, jet diffusion flame, and keep in mind that this is laminar, like I can say laminar jet diffusion flame. And examples, you might be knowing the jet flame, this is nothing but a jet flame, candle flame, droplet combustion, right, and which we will be discussing, and spray combustion, right, and other places you will get, and even the burning of your wood, right, is also an example of diffusion. As I told earlier, most of the diffusion flame will be most of the combustion takes place in nature are diffusion flame, right. And whereas the premix flame is a man-made, and it is in nature it does not occur as such. The partial premix flames, it is the combination of premix and diffusion flame. Let us look at an example of the jet flame. Here the oxidizer are there on the what you call concentrated tube outer jet, and whereas the inner jet is the fuel and oxidizer, that means it is premix already, right. So you will get a two flame structure kind of things, and that gives rise to a combination of both premix and diffusion. And in this case you can avoid the soot formation. The problem with the jet diffusion flame, when it is operated on the diffusion flame mode, is having a soot, which is a great concern nowadays, right. And whereas you can avoid the soot in premixing, and so also the emission level. Now, if you look at, we will be now basically initiating a discussion on the premix flame, and premix flame, as I told, it is nothing but a combustion wave, and this is can be classified in two categories. One is deflagration, other is detonation. So, the detonation is combustion wave traveling at a supersonic speed, right. As I told, there will be combustion wave, the flame will be moving with certain velocity, and that is nothing but a combustion wave kind of things, and that speed happens to be the supersonic speed, and then we call it as a detonation. And deflagration is the basically a combustion wave traveling at a subsonic speed, right. It will be very low values. Subsonic means less than the velocity at which the combustion wave will be moving, right, will be less than the speed of sound. And what we will be looking at now is basically the combustion wave, and we will be discussing about that, and we will be considering one dimensional combustion wave. And as I told earlier, let this fuel air mixture is there in the tube, right. And as I told earlier, if we ignite it, what will happen? That means the flame front will be moving towards the what? For example, if I take, let us say this is a fuel air mixture, filled in this tube, and I am trying to ignite it here, let us say. Igniting means I am giving some kind of energy here, and as I told, there will be ignition kernel, it will be spreading, it will be moving towards here. Why? Because fuel and oxidizer. Will it not move toward this? This also, if there is a mixture, it will move toward this also, but after that this will be only air, so it can't really propagate. But as it is fuel and air mixtures are there, it will be moving, right, in certain velocities, right. Now this is a propagating flame, right. I can call this as basically a flame or a combustion wave. Flame is nothing but your combustion wave, right, and that is moving with certain velocity. Now I want to have a fixed what? A flame at a particular position. What I will have to do? This is the fuel and air mixture is stationary in nature, right. Now I want the flame should be like this, here somewhere located. What I will have to do? I will have to supply the fuel air mixture with a certain velocity. If I give supply this fuel air mixture, right, fuel plus air, okay, mixture with certain velocity, then in such that which will be same as that of the burning velocity, right. Then I will, or I can say this is, instead of this I will say this is burning velocity, then the flame will be remaining stationary in the front. Are you getting? So therefore this fuel air mixture will be supplied same velocity as that of the what you call burning velocity. Otherwise what will happen? It will not remain at a particular position, it will move depending on the mixture velocity. If mixture velocity is higher than the burning velocity, flame will move from left to right. If it is lower, then flame will move from right to left in the tube, right. So that you should keep in mind, and this is, we call it as basically a combustion wave, and this is flame front. I can say it is basically combustion wave, which will be having certain velocity, and we call this SL as also the flame speed, right, which will be using later on, flame speed. And this will be always moving towards the what? Unburnt fuel air mixture, isn't it? The direction is always toward that. Of course, regarding this is very much talked about in our Vedic literature towards what the Agni will move that way. Now, the speed of combustion wave will be basically order of something 20 to 340 centimeter per second, right. Of course, this is for depending on whether the fuel air or fuel oxidizer. If oxidizer is there, then burning velocity or the combustion wave speed will be higher, right. And that depends on the type of fuel mixture. If it is methane air, it will be different. If it is carbon monoxide air, it will be different, and if it will be what you call the hydrogen air or hydrogen oxygen, it will be different. Hydrogen air will be lower velocity as compared to the hydrogen oxygen mixture, and that depends on also the ratio, equivalence ratio, fuel air ratio, whatever it is, it will be dependent on that. We will be discussing more about it, but now this, if it is the speed of the combustion wave will be subsonic, then we call it as a deflagration, right. If it is the speed of this combustion wave speed is greater than the sonic speed, we call it as a detonation. Keep in mind that this we will be discussing further, and keep right, and we will be need to analyze this thing. In the next lecture, we will be discussing how to analyze this combustion wave, considering is to be one dimensional wave kind of things, right. And I will stop over here and we will look at this thing in the next lecture. Thank you very much.